In this video, I'd like to talk about the math question of the day for Thursday, May 4th, 2023. And with this problem, we need to simplify this complex fraction. We have fractions within a fraction. And topics like these are typically taught in Algebra 2 classes, though you might see these in PreCalculus as well. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And with simplifying complex fractions, we need to focus on the numerator and denominator separately and their fractions, in particular, the denominators of these fractions. And we want to think about how to cancel them. Essentially, what could we multiply the top and the bottom by of this entire fraction to cancel out these denominators? And let's start with this 1 over x. If we were to multiply the numerator here by x, then that would cancel out when we distribute here. That would cancel out this x in the denominator with this x in the numerator. So we can simplify that to just 1. Likewise, if we also multiply by y, then that would cancel out this fraction here, this denominator. So that works for our numerator, but we can't just multiply the numerator by x times y. That would change the fraction. We also have to divide by x times y, though that will also help us with canceling out the denominators in these fractions in the denominator of our complex fraction. So in other words, since we're multiplying in the numerator by xy and the denominator by xy, we're really just multiplying everything by 1. We're multiplying this entire complex fraction by 1, since something divided by itself is always equal to 1. And multiplication by 1 doesn't actually change anything, since anything multiplied by 1 is equal to what it started as. For instance, 4 times 1 is just 4, and likewise for any number. So let's actually carry out this multiplication. And we'll focus on the numerator first. We are distributing this x times y to both terms in this numerator of the complex fraction. And let's write that out explicitly. We're multiplying this 1 over x by x times y, but it's also distributed to this minus 1 over y. So we have minus xy multiplied by 1 over y. And now we'll focus on the denominator. We're multiplying this xy into this first term here. We have xy multiplied by y over x. And we are distributing it to this second term here, this minus x over y. So we have minus x over y multiplied by xy. And at this point, we can make our cancellations. Notice for this first term here, the x in the numerator and denominator will cancel out. And for the second term, the y's will cancel out since we have y divided by y, which is just 1. And for this denominator, notice in the first term, the x's will cancel out. And in the second term, the y's will cancel out. So let's rewrite everything. For this term, we just have y times 1, which is y. And for the second term, we have minus x multiplied by 1, which will just be minus x. And for our denominator, we have y times by y for this first term, so that's y squared. And for the second term, we have minus x times x, or minus x squared. And we've simplified this so that it's no longer a complex fraction. But we can make one further simplification, since you might notice that this expression in the denominator is a difference of 2 squares. We have 2 numbers that are squared and we are subtracting. And if you ever have this difference of 2 squares, it factors uniquely. Let's say we have a squared minus b squared. This will always factor to the first one minus the second one. Now we're ignoring the squares. Multiplied by the first one plus the second one. And of course, you can check this by just redistributing and prove to yourself that it does equal this a squared minus b squared. So let's actually carry out that factorization of our denominator. We still have y minus x in our numerator, but in the denominator, we will now factor this into the first one minus the second one, now ignoring the squares, multiplied by the first one plus the second one. And notice that we have this expression y minus x in both the numerator and the denominator. And since we have it in the top and the bottom, we can cancel that out. Since something divided by itself, we know that's just equal to 1. So our final answer then would just be 1 for our numerator divided by y plus x in our denominator. And one way that we could check this is to pick values of x and y and plug them in and simplify everything. For instance, for our original complex fraction, maybe we can set x equal to 1 and y equal to 2, so that we'd get 1 minus 1/2 up top. We would have 2 over 1 minus 1 over 2 down below. So up top, we just end up with a half. Down below, we get 3/2. We're dividing by a fraction, which is the same as multiplying by that fraction flipped over. This simplifies to 1/3. And if we plug these values into our new expression, we can see that we would get 1 over 2 plus 1, which is 1/3. And we get the same value in each, which allows us to feel confident that all of these simplifications we made actually make sense and that this original complex fraction is equal to this new simplified fraction.